Let f and g be two functions with overlapping domains. For all x in common, they can find sums, difference, products, and quotients using the following notation. So if we see f plus g of x, that means add your functions. F minus g of x, subtract your functions. F times g of x, multiply your functions. F over g of x, divide your two functions. Very straightforward. Let's try a few examples. We're given f and g, and they want us to find f plus g of x, then evaluate it when x equals 2. So f plus g of x equals f of x plus g of x. So f plus g of x equals x squared plus 1 minus x. Now I prefer to write my sums, differences, products, and quotients in standard form, x squared minus x plus 1. Now they want us to evaluate this sum for x equals 2. So I'm plugging 2 into the sum I already calculated. 2 squared minus 2 plus 1. F plus g of 2 is 4 minus 2 plus 1. F plus g of 2 is 2 plus 1, which is 3. So when I plug in 2 into that sum, my output is 3. Same two functions, but now they want us to evaluate the difference and then plug in 3. So f minus g of x is f of x minus g of x. So f minus g of x is x squared minus, now notice since I'm subtracting, I'm going to open up parentheses and then plug in my function, because now this negative needs to get distributed to both parts of g. So f minus g of x is x squared minus 1 plus x, or in standard form, x squared plus x minus 1. Now we want to take this difference and evaluate it when x is 3. So that's going to be 3 squared plus 3 minus 1. F minus g of 3 is 9 plus 3 minus 1. F minus g of 3 is 12 minus 1, which is 11. My input into the sum was 3. My output is 11. Let's keep it going with a product. Now we are trying to find f times g of x. That is f of x times g of x. So f times g of x is x squared times 1 minus x. F times g of x is x squared minus x cubed. I always prefer standard form, negative x cubed plus x squared. Now we want to evaluate this product. For x equals 3. So that's going to be negative 3 cubed plus 3 squared. Now remember, we have to follow order of operations, do exponents first. Negative 27 plus 9. So f times g of 3 is going to be negative 18. My input was 3. My output into that product is negative 18.